data and technology theme. So we have two speakers. First one come up will be Felipe Diaz. So he's.
So, am I already going to start my stuff?
Not yet. Let me give you
Okay.
brief introduction.
Oh.
So Felipe is a transportation planning engineer. So he has been working on data science, spending a lot of time doing coding and data analytics using Python and R. And he has both experience in academia and industry. He has earned a bachelor's degree in environmental engineering, and he has two masters. One is in statistics, and the other one in transportation engineering, and also PhD in civil engineering. So he has experience working transportation planning, engineering, consulting in both US and Brazil. For past decades, he has been handling data and using it to extract useful and actionable information. So he has been working on travel demand modeling, corridor studies, economic metrics, behavior modeling, and big data manipulation. So let's welcome Philip.
Hello, everyone. Can you hear me all right? Am I coming through fine?
Sounds good, yeah.
All right. Thank you for that very kind introduction. So yeah, I'm going to talk to you all today about this activity that we underwent here at Jacobs, where we extracted a lot of trip information from very raw XY coordinate data. So let's jump into it. Here, and let me go into presentation. And I want to have this guy, and here. All right, so now my screen is set. Like was mentioned before, I am originally from Brazil. I graduated from the University of Sao Paulo, from the Polytechnic School there. I spent most of my life in Brazil, and it's been 6 years now since I've been in Texas. Very, very happily living in this very different place from Brazil. I came to Texas to pursue my graduate degree, to get my doctorate. And after concluding my PhD studies, I was hired by Jacobs, where I've been working for the past year, and where I've been getting to put a lot of the theoretical stuff that I've learned in grad school to actual practical use. Oh no, I did not want to turn off my video. That is not. There we go. I just wanted to switch slides. I'm going to talk to you here about the project that needed this data assessment. So this was a project called the Western Connection Needs Assessment. Essentially, what our client wanted was that they wanted to study the potential for the need for a new highway alignment that would connect US 59, which is this south to northeast highway. They wanted to see if they needed to make a new alignment between here, this highway, and I-30, this big thick line here from east to west. And the area of consideration is this green area. So there is already US 59 that goes up north here. There is I-369 that goes north, and there is I-30 that goes west. The idea is, did they need to build a new highway that went straight from here over to I-30, more direct connection to I-30? pretty simple question, and as we all know in consulting, simple questions typically lead to very, very complex answers. What I'm going to show you all is a lot of what we've done with our actual coding strategy. Most of my presentation today is going to be focused on looking at a bunch of little code snippets and the ideas of what was going on behind these things, and like how simple it is to do some of these things with a lot of these libraries that exist. So, like I mentioned earlier, our goal was to extract trip information from this time-stamped XY data, this XY location data, and we wanted to understand vehicle movements by these origin-destination pairs. So, what data were we working with? We were working with the ATRI data. ATRI is the American Transportation Research Institute. They have very, very good data about trucking. They claim that their data representativeness is between 8 to 10% of all active on-road truck population. So that is a significant amount of trucks. So if we can figure out what's happening with the trucks in their data set, it's likely we're going to have a very good picture of what's happening with trucks in general. This is what the ATRI data looks like. For privacy reasons, I'm not allowed to show you the actual raw data. So this is just funky data that I made up that has the same structure of it. So it's very, very simple and straightforward. It's a timestamp, longitude, latitude, the speed of the truck, and a little truck identifier that allows you to see what multiple points the same truck made. And GPS locations are emitted every 60 seconds or every 400 seconds on average. When I say 60 or 400, when we looked deeper into the data, we noticed that there were two types of trucks. One of them emitted signals every 60 seconds, and the other one emitted signals every 400 seconds on average. So what did we use to analyze all of this data? So the very initial step was, well, we're going to play around with Python to manipulate this data set. We are using a lot of NumPy. The main workhorse of this whole operation are pandas and GeoPandas. These are data manipulation libraries in Python. Super, super powerful. Pandas is super famous already for data manipulation. It's very similar to dealing with data frames in R, if you're familiar with that. And GeoPandas is essentially an extension to Pandas that allows you to have some control over geographic mapping tools and GIS-related functions. I'll talk a little bit more about those. The IDE I used was Spider. I know that most true Python coders do VS Code or a few other tools. I am kind of older. I really, really enjoy the functionality of Spider. I will die on this hill. This is a good IDE. And also ArcGIS Pro and QGIS, these were other tools that we used to like visualize some of the geographic results that we had. So let's get into what the processing logic looked like for this whole data set. Essentially, there were 4 big processing steps. Step number 1 was read in the raw data and sort this data by truck ID and timestamp. Step number 2 is for each truck ID, find the break between trips, see where the trip actually broke, right? If we have multiple points for one truck, we have to find out, okay, it started a trip here and it ended that trip over there, and then 4 hours later, it started a new trip and went somewhere else. So we needed to find where those breaks were in the data. let me get into this first step, the dealing, first step, which is just reading in the raw data and mostly sorting it. This can be really, really easily done in pandas. One curious thing that we found was that when we read in all of our data, there were weirdly some duplicate points, like the same XY coordinates, the same truck ID, the exact same timestamp, and we wanted to, find unique point IDs such that these guys could be filtered out. So one very simple way of doing this was creating a big long string that concatenated all of the main data here. We hashed that string. I just created a hash function. I just used one of Python's already built-in hashing functions. And what this does, it takes this arbitrarily long string, and it produces a uniform sized string. So something that looks like this up here on top, this 2019-06-24, blah, blah, blah. This, it has all the relevant data. We just hash it, and it comes out like this. It's kind of garbled, right? It doesn't really tell us anything, but it's this unique identifier. We could have stuck with just this, but we just wanted to have something that looked more unique, more identifiable. And once we have this, we can just group by this point ID, take the first element that's found in the data set, and that's it. That's how you can very easily deduplicate data. There's also another drop duplicates command, I believe, in pandas. Also super easy, super straightforward to use. I just wanted to show this, and you all will notice that if anyone here is familiar with coding in R, and specifically using the tidyverse library, the coding style that I'm using here kind of resembles that. So yeah, just there are things that translate from one language to the other very well. So another really important tool in our dealing with this whole data set was the GeoData frame. It's like I mentioned earlier, from GeoPandas, it expands the notion of a data frame, and it also gives you access to this spatial functionality, like seeing from a whole data set, from a whole table with a bunch of geometries. I can see which one of those intersect with one specific input feature, with one specific input geometry, and it super quickly does this. It's powered by a library called Shapely in the background. Another thing that can be a nightmare to do is like converting between coordinate systems. This is very simple to do. So this is what it looks like to load in data into GeoPandas. So you just call in the GeoPandas library itself, .geodataframe. You pull in your points. You declare what coordinate reference system you're using. This was originally using this 4326. That's the WGS84 coordinate reference system. And what is the geometry that we're slapping on to this new data frame that originally was just a table? We generate this points from XY using the XY columns in the data. Super simple, super straightforward. The original data was in WGS84, and I wanted to convert it to not a degree, like I didn't want to have degrees. I wanted to have actual meters or feet on the ground, actually have projected coordinates. So this is what you need to do to just change the projection. You just write to CRS and you are able to change your projection. Step number 2 is one of the trickiest parts here. It's finding how you break the trips. We tried a couple of different things. The one that worked the best for us was setting a time threshold and a distance threshold. So if 2 consecutive points were more than 30 minutes apart, or more than however far a truck could travel within 30 minutes apart, we said, okay, if any of those 2 are violated, we're going to say that this constitutes a new trip. So maybe a truck drove one place, it turned itself off, it turned the logging system off, and then it went somewhere else, started a new trip. If those 2 consecutive points are very distant from each other, then we know that there is a new trip starting. Or if a lot of time has passed, right? It's the end of one day. It's the last point seen from one day was at 9 p.m. and then the next day at 9 a.m. we see a new point. We know that those 2 aren't from the same trip. There was a big interval between them, so we also cut the trip there. This little chunk of code here just says where the new truck ID, where are there going to be new truck IDs, where trips are going to be split. And we create this pre-trip ID, which is just a cumulative sum of where those trips break. And connecting the dots, this is something that I imagined when I started this was going to be one of the hardest things, which is connecting one point after the other, or just figuring out a way to do it. It's actually super, super easy. Once we had this data frame of all the XY coordinates and the unique identifier of the trips they belonged to, we were able to just group by those trips and apply a lambda function to their geometries, and just say, if there are multiple points, make this a line string. If there's just one point in this trip, just give me that single point. This is super simple. It just, like the illustration I painted down here on the bottom, it just takes these groups of points and it actually connects them and makes these new geometric features. I talked about the directional gates. What are these directional gates? So we wanted to evaluate how many trips went through a specific region, or more specifically, we want to see how many trucks went from one place to another place. Or to be more precise, it was how many trucks there were that went through one location and later went through another location. The problem with that is that if we have these 2 locations, if you don't set the direction in which the truck was traveling, you don't really know if they went origin to destination or destination to origin. So one trick that we did was to have this gate, right? We had this capture area to select what trips were in a certain location, and we got this vector to determine, okay, I only want trips that go in this general direction. If the angle between this general direction and my trip is greater than 90 degrees, I don't want that trip. That trip doesn't count. That's not going in the right way that I want it. And finally, counting how many trips there were. We just made a few locations. We just created these location objects, and we said, okay, from this location to everyone else, how many trips are happening from this second location to everyone else, from this third location to everyone else. And we did this pretty straightforward. We had a dictionary called OD groups, and we would have origin group 1, destination group 1, origin group 2, destination group 2, like I have here, and we would just say from this place to all other 3 places, from this place here to all other 3, and all the multiple iterations of that. Super simple, super straightforward. This I'm going to bring back of nightmares to a few of you. I'm sorry. Just remembering stuff from linear algebra class. This is the concept. These are some of the very simple concepts we use. Like I spoke earlier, we had that reference geometry and the reference location. The reference geometry and the reference direction. If a trip was being made, and the trip I'm considering this black arrow here. If the angle was less than 90 degrees, then that's cool. We would count that trip. And if the angle was larger than 90 degrees, then I would throw it out. And we calculate it. We calculate the angle by just using very simple linear algebra operations in Python. So finally, after all of this, we get to a really, really nice, simple result, which is from that origin down here, we saw that the vast majority of trips were just going up north. They were continuing up north on this other highway, and very, very few of these trips were coming west. Very few of them were going up here north and turning west. So in the end, it seemed like this new infrastructure that our client was considering to build wasn't absolutely necessary. I know I went through a lot in very, very minor detail. So if anyone has any questions, I'd be more than happy to answer any of them. Here are my contact details and contact details for other members on my team who helped on this project and who helped me put this presentation together. And thank you all very much for the invitation, for inviting me here to talk to you all.
Yeah, thank you, Felipe. Do we have any online questions? What about any questions on the floor? Maybe I ask a question first. Felipe, I know you the A3 data seems very good. You have high representation at 8 to 10%.
Yeah.
Did you get a chance to explore any other data source or platform could it be used for similar studies? For truck movement?
We did take a look at a couple of other data sources. The thing was that this was our first experience with A3, and we wanted to give this data set a shot, see what it was capable of, see what we could do with it, the valuable information we could draw from it. So we ended up focusing mostly on A3 with this project. I believe other members in my team might have used other sources to compile the final analysis, but my small group was focused on just giving A3 a shot, seeing what valuable stuff we could extract from this.
Gotcha. Anyone has more questions? Here you go, Shirao.
Was there a cost associated with use of the data, or was that is that a public available?
So I just to restate the question, and correct me if I'm wrong, you were asking what is the cost associated with this data, correct?
Right.
Okay. Unfortunately, due to privacy agreements, I am not allowed to disclose that kind of information. I apologize.
So at least it's not a public available. Is
At
it,
least it's not what?
is it available to general public use? Or is it paid?
What do you mean
access?
I believe anyone could get in touch with Atri and purchase the data. I'm not sure if there is a public version or a public sample that's freely available. I don't believe that that's the case.
Gotcha. All right. Thank you very much, Philip.
Thank you again.
So, next speaker. So coming up next is a familiar speaker, Andrew Heath from GDOT. He joined GDOT in 2008. He has held numerous positions within the department, including within Office of Planning, Executive Assistant to the Chief Engineer, and most recently as State Traffic Engineer within the Division of Operations. He has a bachelor's degree and a master's degree from Auburn University in civil engineering, and there is a PE in the state of Georgia. So he's going to bring us some updates on two very interesting topic and topic I know we all are very care about very much. One is on update on the GDOT CAV program, and then the second one is regarding the traffic analysis guidance matrix. So let's welcome Andrew.
Thank you, Shui Wen, and thank you all for having a great in-person conference. It was wonderful to be here. It's wonderful to have GDOT folks be able to attend. We're looking forward to re-engaging industry more at events like this as we hopefully continue to emerge from the pandemic. So it's been great. Thank you especially to Bill for pulling this off. I think it's been absolutely wonderful. As Shui Wen said, I've got two topics this morning, but I'm happy to talk about whatever you guys want. So feel free to ask away on any GDOT related items. I'm an open book. I realize that I stand between you guys and the road or the beach if you're staying for some vacation, so I'll be as quick as I can. But I'm actually going to start with the GPTQ stuff. It's probably the more mundane topic. The connected vehicle stuff is more exciting. So let me jump down. Okay. So we'll start with an update of the GPTQ Traffic Subcommittee. By show of hands, how many of you know what GPTQ is? Okay, that's almost everybody. That's good. That's good. It wasn't quite all. So just very quickly, if you don't know what GPTQ is, the Georgia Partnership for Transportation Quality is a long-standing partnership between ACEC Georgia and GDOT. And the mission of that organization is to strengthen the working relationships between the parties that are responsible for designing, building, operating, and maintaining Georgia's transportation infrastructure with the goal of making it the best it can be. You can see a very simple diagram I threw up there of how GPTQ was structured with a leadership forum at the top, then a steering committee below that, and then a whole series of subcommittees in which traffic engineering is a subcommittee. There's actually about 20 or so that make up the entire body of GPTQ. But the whole point of it is to talk and collaborate and work through issues that industry might be having with the department, that the department might be having with industry, and find common ground to move forward to deliver the best transportation system that we can in the state of Georgia. So for 2021-2022, the traffic subcommittee membership is as appears on the screen. I, along with Andrew Antweiler, chair the traffic subcommittee, but you can see Mike, who's in the audience, is part of it. Marco, I think, is in here somewhere as part of it. Bill, part of it. But you can see the full roster there of the folks that serve on the subcommittee. So if you guys have issues that you want to talk to GDOT about, or vice versa, this is a forum that's available to introduce those topics, introduce those concerns, and we can hash those out, talk through them, and hopefully arrive at common ground to, again, do better from a partnership perspective between the department and industry in moving our transportation system forward. So one of our main topics that we've been developing and discussing as a subcommittee over the last year or so is what we call the traffic analysis guidance matrix. And the motive of this was to provide clear, consistent guidance on traffic analysis deliverables and documents for projects that are following the PDP, the GDOT PDP process. So think if you're working for an A&E firm and you win a 2 to 4 lane widening from point A to point B, and one of the things that you got to do as part of the concept development is conduct a traffic analysis to justify that project, that need and purpose. Well, what do? What analysis do you do? What tools do you use? Who do you submit it to? Who's reviewing it? What are they looking for? Who's approving it? We talked through this as a subcommittee and realized that for a lot of those questions, the answer is, I don't know. Someone's looking at it, I guess, but I'm not quite sure what they're reviewing, what they're approving, what they're looking for to justify the investment. So the purpose of this guidance matrix is to answer those questions and to give an engineer, as they get that type of scope from the department, some clear guidance on this is the path that I need to take to move forward so that I can check every box from a departmental perspective to say, yep, this is exactly what I need to be doing. Clear guidance, clear expectations, and then we can speed up that process and get these projects moving. So again, what are we asking for? What performance metrics need to be included in that traffic analysis? What tools? Is it HCS? Is it Synchro? When does something cross the threshold that we need a full VISIM model developed? And who's actually looking at the VISIM model and the assumptions that are included in that to make sure the department is comfortable? What documentation is needed? Do I need a 200-page traffic analysis report? Or can it be something a lot more simple than that, that we can very quickly answer the questions that we have as to the project justification and the scope? And then who is reviewing? Where do I submit it? Do I submit it to the district traffic engineer? Do I submit it to Georgia DOT and hopefully it gets routed to whoever needs to look at it? Do you submit it to Andrew Heath? Provide some clarity on that. And then what is that approval process? What is the routing process? And who's going to sign the, check the box to say this is exactly what we want to do? So you guys probably can't see this, and that's fine. Don't worry about that. But what this table shows is a whole series of project types, all the way from an access permit to a median opening to a new traffic signal request to a interchange reconfiguration or an arterial widening. We've sort of grouped those project types into what we call levels of projects, all the way from level 0, very simple, to level 5, something very complex. Think of like an MMIP project, traffic analysis. Very robust traffic analysis that has to go into that. And then what all is included, what's expected, and that's where you see these Y's and P's, meaning yes, you need to do that, or you need to partially look at this, et cetera, et cetera. So it's kind of guidance to look at, okay, I've got a client that's asking me to install a driveway with a traffic signal, right? That's pretty well understood in the department. That's probably one of the more simple processes well, not simple process, but one of the more understood processes we have, but it shows you how to do that. Or I've got a client that says, I want to widen this road and it's got GDOT oversight. What is expected of me from a traffic analysis perspective for documentation and inclusion to submit to the department from an oversight perspective? So it gives you that guidance to say, okay, here, I've got this project type, it's this level, I need to do these things. So hopefully, as this gets introduced into industry, it does provide some clarity to this entire process. Now, I want to be very clear, what we're talking about here is not design traffic forecasting, right? That very familiar process you go through with either the Office of Planning or with my office for some of the projects that we manage. We are not talking about replacing that process. We're talking about, you've got design traffic, what analysis are you going through to justify the need and purpose and the concept for the project that you're working on? And then who's looking at it, who's reviewing it, and who's approving it? The guidance matrix also includes that approval routing process. So for the levels of the type of projects, where is your initial contact? Is it with the district? Is it with the planning office? Is it with traffic operations? Who's reviewing? District, TMC, what office? And then what is that final approval? Can it be approved at the district level? Can it be approved at the TMC level? Or does it need to go all the way to the chief engineer for her final sign off and approval? So this document is now complete. And for every single one of those project types, we have essentially what we call a workbook, or it's a tab in the document that includes those very specific details for each project type. And then it has a series of links for examples. So if you want to see an example of it, an agreed upon best practice from a widening perspective, a traffic analysis for a widening project perspective, there's a link to one to take a look at and say, okay, if I do something like this, this is generally what the department's going to be looking for. You can step through any of those, click on them, find those details, find those examples to provide the guidance that you're looking for, so that as you receive that scope, there's a clear path forward to deliver, right? And hopefully eliminate confusion between the department and industry as to what's being looked for, and quicken that concept process, because as you guys know, that process is one of the slower processes we have, frankly, to just get something started. So hopefully, again, it provides some clarity and improvement to that overall process. So this document has been reviewed by GDOT Traffic Operations, Design Policy, Program Delivery, Planning, Roadway Design, and we sent it to other GPTQ subcommittees that might be affected, including Innovative Delivery, Procurement, Program Delivery, and Roadway Design. So we have had a pretty robust review process. That was frankly a lot of the timeline in getting this thing done, was to get through all those reviews, make sure we are capturing everything appropriately and weren't missing something along the way, so that we had conflicting guidance out there from what we were already doing. It's under final review by GDOT currently, and we're going to be publishing this to the external website for everybody to have access to. All right, so as this gets published to the website, we will communicate that so folks can have access. And this is the guidance tool, right, to help you as you work through GDOT related projects in getting through this traffic analysis piece as cleanly and smoothly as possible. Some other activities from the traffic subcommittee. This past year, we reviewed the updated traffic signal specs, so we provided reviews and comments to those specifications. And as GDOT continues to update specs, we'll be routing them through the subcommittee, whether they're signal related, ITS related, or just anything related from a traffic perspective. I view the subcommittee as a resource for GDOT to make sure that we're speccing the right things, asking the right questions, making the correct updates, and not inadvertently stepping on a landmine that we may be unaware of. And then we also reviewed a brand new document that we'll be publishing in the coming months called the Traffic Signal Operations Guidelines. This is a document that just pushes out guidelines as to how we as GDOT like to see traffic signals operated, right? Right now, we've got a series of policies, guidance, pieces here, pieces there, and frankly, we've backed ourselves into a corner on a few issues from a liability perspective as to how we're communicating how traffic signals should be operated. So this is an attempt to retire certain policies, pull information from here, pull information from there, and bring it all together into one overarching signal operations guidance document that we can give to industry to say, from a DOT perspective, this is what we look for. Whether it's from a SIGOPS perspective, statewide, or whether it's from a local operating a traffic signal on the state route system, this is the guidance that we have, right? We're being very careful on language with this, as you guys might expect. A lot of mays, a lot of shoulds, probably zero shalls in the entire document. But it's, again, guidance for industry as to what we're going to be looking for from this particular issue. And my last bullet there is, how can we help as a GPTQ traffic subcommittee? The first thing we do when we meet as a group is we say, who's got an issue that we want to hash out? So I want to open that up for all of you. That you saw the roster. Andrew and I are co-chairing. We want to hear those issues. We want to debate them, deliberate them, and find common ground, find solutions so that we can resolve those issues and continue moving our industry forward, because I think it serves all of us in a good way to hash through these things. So that's my GPTQ update. I'll take any questions at this point as it relates to that. Okay, well, that was easy. Yeah, Carla.
There's been some debate as to how to justify a left turn protected arrow for a signal. Is GDOT going to formally put together some document on the left turn signal? I mean, I always followed the cross product, the number of accidents, and the highest peak traffic volume. But then I've heard that some of that is not enough, or it's being done, something else is being done. So are y'all going to do any kind of formal policy? This is going to be the way?
Yeah, this document will include guidance on permissive versus protected lefts, that exact issue. And frankly, that issue is one of the issues that elevated itself that led to the development of this document. It wasn't necessarily the cross-product piece of it, but it was surrounding the crash history of that conflict of left-turning vehicles, where we had some policy language that was not the best. So as part of this whole effort, we're looking to clarify all of that. Okay. So you'll see that addressed through this document and through subsequent updates to existing policy. Good question. Okay, one down. Let me go back to the top. All right, so this is the fun stuff. First and foremost, I got to thank Alan Davis. He made this whole presentation, so I just stole it from him. So I really appreciate his work. Just to be clear, the Georgia Connected Vehicle Program is one person, frankly. Alan does basically it all. He has support from his staff, and they do a tremendous job helping him. But he has really taken this by the horns and ran with it. And Georgia has become a leader in connected vehicles very quickly. If you rewind the clock 5 years, we were nowhere on the map. It was Michigan, Utah, and Florida. And we decided to jump in and have passed the group, in my perspective, and are now leading the charge, where as the issues surrounding connected vehicles play out on a national level, these organizations are calling us now, which is tremendous. To have that input at the national level with the FCC, with the Government Accountability Office, having those direct discussions from Georgia to them, shows where we've come as a program, and it's been under Alan's leadership that's made that possible. So he's just done a tremendous job with all this, and I really appreciate his work, because it has, again, elevated us nationally from a technology perspective to the front of the group, which is absolutely incredible. So let me just talk briefly about the signal and CV investments we've made programmatically. And that's one of the things I like to talk about with our connected vehicle program, is that it is a program. We are not about pilot deployments. We are not about a project here or a project there. We're about how do we stand up a connected vehicle system programmatically and layer it on top of our existing investments like SIGOPS. When you think about SIGOPS is it's not any longer a project here, a corridor there. It is a statewide initiative that GDOT follows and conducts on a programmatic basis across all traffic signals under our purview. That's the approach we want to take from a connected vehicle perspective, because it's one thing for a connected vehicle solution to work on this corridor. But if we want this technology to be adopted by OEMs on a broad scale and to proliferate through the market on a broad scale, it's got to be a holistic program. This technology has to work across Georgia, and not just across Georgia, but across the country. Otherwise, who's going to invest in it? Who's going to buy it? All right, if your cell phone only worked you're in your house and nowhere else, would you even own a cell phone? No. Just be a cool little gadget maybe that somebody might buy, but it wouldn't be fully adopted by society, right? That's what we need from a connected vehicle perspective, to start realizing safety and mobility benefits. And that's our approach from a CV perspective. And that has shown through when you talk about things like traffic signal software, advanced traffic signal controller software, central management software, GDOT purchased licenses of that software for every traffic signal across the state, whether on system or off. And we offer it for free to locals if they want to use it, right? All about having that consistent programmatic platform. We have rolled out traffic signal communications through 4G LTE to over 8,000 traffic signal locations in Georgia, 8,000 of 10,000. So that's well above just what's on system. That includes off-system locations as well. Again, a programmatic rollout from a communications perspective. Open data through ATSPM. All of you guys are familiar with what we're doing from an ATSPM perspective and how we're looking at data to manage corridors or manage zones and aggregate that all into holistic performance metrics across the program programmatically, right? We're not just looking at it for here or there. We're now looking at it as how are we doing as a state, whether it be South Georgia, North Georgia, Metro Atlanta, applying these metrics across the entire program. And then creating an open platform to make all of this information available, right? So that anybody that wants to have it can use it and develop a specific use case or specific application out of it. And then you get into, again, the similar style approach from connected vehicle software. We have upgraded all of our traffic signals so that they are CV ready, right, through the MaxView software program. Everything we're doing is through the 5.9 gigahertz safety spectrum, right? Everything we're doing is open source, following national standards. Things like that. So again, it's a programmatic approach to what we're doing. We don't want to be a one-off thing here. We want to do it where we're elevating the entire the transportation system and overlaying connected vehicle as that next layer, that next emerging technology layer, so that is widely available regardless of who's going to use it and for what use. It can be understood, used, and put to good use from a safety or mobility perspective. So let me get into the timeline. Our connected vehicle program started in 2017. We started the program in answering what was known as the AASHTO SPAT Challenge, Signal Phase and Timing Challenge. And that challenge was to deploy connected vehicle technology, at the time DSRC, at 20 locations in all 50 states by the year 2020. We, being GDOT, said, well, we'll do 54 instead of 20 because we're overachievers, and that's just what we like to do. We got that up and running. We conducted a systems engineering effort as part of that work, and we deployed those radios and started broadcasting signal phase and timing information by June 2018. And we developed some traffic signal-based applications, including red light running, countdown to green, and green speed optimization for those two corridors that these radios were deployed at. That project went very well for us. But then we started having that conversation about what are we doing programmatically? How are we going to take advantage of the work we've done through SIGOPS and other programs to expand the reach of the connected vehicle program that we have? And we decided to embark on what we call the regional operations expansion, or essentially introduce connected vehicle technology to the entirety of what was then the RTOP system, or 1,600 signalized intersections across the Metro Atlanta region. So this was our first step to say, we're no longer doing pilot projects. We're not doing one-offs. We're approaching this from a programmatic perspective. And we started expanding that system in 2018, and we introduced additional applications like transit priority and emergency vehicle preemption through that work. That work actually caught the attention of US DOT for an ATCMTD grant. We put in an application for that. They awarded us $2.5 million to accelerate the deployment of that infrastructure because they liked our programmatic approach, and they thought it spoke well to the ongoing discussion that was going on with the FCC about the future of the 5.9 gigahertz spectrum and the challenges that it was receiving due to the spectrum laying fallow. We wanted to show that no, it is being used, and this industry is standing up and addressing that concern. So we continued that build out through 2019, and then in 2020, we expanded that through a partnership with ARC to move beyond just the RTOP locations and start deploying this technology at off-system locations as well, essentially beginning to fill in the gaps across the region with a target of 1,000 additional intersections through this particular program to really ramp up what's going on in the Metro Atlanta area. Of those 1,000, we are currently under contract for over 700 that are being deployed through that program. And we're hopeful, obviously, to cross that threshold and get to even more locations. That is set up for those of you that have local agency clients. That particular program is set up where ARC is paying 80% of the cost if they want to deploy at a location. The local cost for deploying and having essentially a turnkey solution to deploy at a location is about $1,600 an intersection to introduce this technology. So it's, from my perspective, relatively affordable for a local that wants to get engaged. And then just this past year, we won a second grant, a $3.2 million grant to outfit all of our Hero fleet with onboard units and introduce specific emergency vehicle preemption applications at interchange turnarounds as they are operating in emergency fashion to respond to something that has happened on the other side of the incident. All about reducing the incident management timeline and getting both Heroes and actually a partner in Metro Atlanta Ambulance for them to respond as well. So they will receive essentially that green ball as they're approaching interchange intersections so that they can proceed through in a much safer way and in a way without conflict to hopefully respond much more quickly than they previously have. So as you can see, robust growth of the connected vehicle program just over the last 5 years. To sum that all up, that's over 2,600 RSU locations to be deployed through all of these programs. That is the largest number in the country. So you can kind of see where we're going as a state agency on this. Still big believers in the potential of this technology, and we're going to continue to move down that path. Here's a map just kind of showing where we have roadside units deployed. Obviously, most of the deployment in Metro Atlanta. The lines there are the original regional operations expansion of this technology. The stars, those dots, that is through the ARC program. Those are the local agencies to date that have signed on and said, yep, we want to be a part of that. We want to deploy this technology. You can also see we have a small deployment on the Ray through a partnership with that foundation that I'll get into here in a second, down on I-85 near West Point and the Kia plant down there. And then we have a deployment in and around the ports, Garden City Terminal. How can we help trucks move in and out? You heard Tom McQueen talk about that yesterday. How can we help ingress and egress from that particular facility and help make our freight operation just a little bit more efficient down there? And then you can see one dot in Statesboro. We stuck a radio out there for some research work that we have going on with Georgia Southern. And our particular partner down there is very excited to have an operational radio down there that he can play with. So that's kind of a broader view of what we currently have out there on the roadway network. Just zooming in on Metro Atlanta, you can get some more details about where specifically this infrastructure is and specifically what local agencies have signed on through the ARC program. Agencies like Johns Creek, Henry County, South Fulton, College Park, you name it, folks are beginning to jump on. And we've seen accelerated growth as the program has started, and others have taken a look at it and said, yeah, we want to be a part of it too. So we're excited about where that's going. And what's very exciting is you can start to see that map really truly being filled in as it comes to this technology being proliferated. So from a V2X framework perspective, this is how the department views both safety data and mobility data. Sort of two paths. One is really entering into the world of V2V, but that's safety critical information that has to happen at extremely low latency point-to-point communication between vehicles. So we can ultimately get to things like collision avoidance and crash mitigation. You know, if you are on a trajectory to hit another vehicle, that vehicle needs to know immediately. We don't need to send that back to central to then process, push back out, and communicate that in a much lower latency fashion. That's got to be point to point. So that's how we're viewing that. And part of that is, what is the role of DOT in enabling those applications, if there is a role at all? We still have to see how that plays out and what the OEM adoption is going to be for this technology. But then moving down into the mobility piece, maybe there's the ability to be a little bit slower in communicating that, because you're talking about things like queue warnings that might be downstream, a mile downstream. It's okay if that information takes a second or two to make it to a vehicle. So those mobility-related applications, for that, we've developed an open data portal that anybody that wants to pull down the SPAT data that we have at all these locations, they can have it, and you can start developing applications, third-party applications, utilizing that data, understanding that the latency may be a little bit slower, but it's a much quicker way to proliferate the impact of the data that we have through the Connected Vehicle Program as we expand our reach. So kind of two tracks that we're looking at, both from a safety and mobility perspective, really trying to focus the infrastructure or focus the architecture around the need, either safety or mobility. Applications we've enabled today, to talk a little bit about this, but emergency vehicle preemption is enabled. We've demonstrated that in Gwinnett County with some of their fire trucks. Transit signal priority is up and running on a deployment with CERTA, Greta, on their express buses as it operates in the midtown and downtown areas. Freight priority that we are looking to stand up, currently underway down at the Savannah ports and communicating things like blocked at grade rail crossings. And then a series of signal phase and timing related applications like optimized green speed, red light running, things of that nature. So that's kind of what we currently have from an applications perspective. Again, the good thing about this is programmatically, these applications have been built. They work at location A. If we want to translate that to location B, we can very easily do that. It's just building the parameters around that specific use case and running that application there. The work is essentially done at this point. So a little bit deeper dive on the ATL, transit signal priority. This is the installation of roadside units at the intersections you can see on the screen. This is Spring Street and, not Spring Street, Cortland and, what is it, Alan? Spring and West Peachtree, sorry, yeah, Spring and West Peachtree. This is the CERTA Greta's Route 431, which is their most challenging route from a reliability perspective. We have equipped onboard units on 10 of their buses that are requesting priority if the bus has a certain occupancy level and if it is running a certain amount of time behind schedule. Then it will request and we will grant priority for them to proceed. You saw discussions on that through some of the BRT presentations just yesterday. Broadcasting SPAT and MAP that the buses are receiving and traveler information for roadway conditions, and we are running that priority application. This is in operation. It went into operation in March of this year, and it's working. We don't have specific information on how reliability has improved, but anecdotally, we are seeing buses arrive ahead of schedule. So CERTA, Greta is having to kind of slow things down a little bit because the system's working too well. So we've got to fine tune that a little bit, but we're going to do some post-processing work here to see what has reliability jumped from. A similar deployment in Utah saw reliability jump on their bus system from 90% to 97%. So it really helped them out on their system as well. So we're looking for similar results as we get into the data on this particular project. But again, we did this here. If we identify another location where reliability is a concern and something like a priority application could be needed, we can easily translate this work to that other location and run a similar application there for that specific use case. Similarly, for the pilot project down at the ports, this is roadside units at signalized intersections for port ingress and egress. So this is State Route 21, State Route 307, and and Jimmy DeLoach Parkway. So we've deployed roadside units on those routes. Again, focusing on a priority application very similar to transit signal priority. It's just equipped on trucks rather than buses. And we have lined up 2 private providers, freight providers, that have yards just outside of the ports that do a lot of essentially last mile running between their yard and port property to bring in and out containers. We are equipping OBUs on their trucks, so they've actually sort of signed the dotted line with us. So yeah, you can put your stuff on our vehicles, which is a big deal. I mean, that's a hard bridge to cross for a lot of private providers to allow that to happen. These guys have signed on and said, yep, we're willing to be a part of it. We're excited about what kind of reliability improvements, efficiency improvements we can give to them to impact their bottom line, frankly, as they conduct their business in and around the port. So excited to see where that goes. Hopefully we'll get some other providers lined up and identify some other use cases, maybe not immediately at the port facility, but somewhere where we can help address freight concerns in and across Georgia. And then finally, the RAY project. This one is very exciting for us. This is a two-phase project that's underway. We have deployed dual active roadside units that operate through both DSRC and C-V2X, so it's technology agnostic from a communications perspective. It's a partnership between the RAY, GDOT, Panasonic, Kia, Hachi, which is the R&D arm of Hyundai, and Federal Highway. And not only, why this is so interesting is that not only is it expansion of our connected vehicle program at intersections, we have also deployed rural interstate applications. So we have essentially mainline radios on a rural interstate setting, which we don't have anywhere else in our connected vehicle program. And we're running things like crash alerts, queue warnings, and weather alerts. This is what I call a full live connected vehicle environment down on the RAY, where not only are we broadcasting information, we're pulling information back in from vehicles, right? So we have OBUs equipped to the CAN bus of the vehicles. As they drive along this corridor, we are collecting that data from these vehicles. It is coming into this, what we call the Cirrus data ecosystem, which is a Panasonic product, to analyze, interpret, aggregate, and understand what's going on from a vehicle perspective as they drive up and down this corridor. We've equipped 4 GDOT vehicles with C-V2X OBUs. They're District 3 vehicles that are actually down in this immediate area, so they are routinely driving the I-85 corridor. And as part of our Phase 2 work, we are equipping 10 Kia executive fleet vehicles that are down, essentially assigned to the West Point plant. So these are the vehicles that the plant manager and those types of folks drive around the area on any given day. They're going to have OBUs installed, so we're going to start pulling in information from those vehicles as well. This entire system is actually secured through an active SCMS deployment through ISS Green Hills, the vendor providing that. And what's crazy about this is we stood this up, we launched this ecosystem, we enabled SCMS so that the only folks we can talk to are security compliant and the only folks that can listen are the same. And as soon as we did that, the next day we started getting data. And we weren't driving down there, Kia wasn't driving down there, it was people. But we are collecting BSMs from people. We have no idea who they were. It was somebody driving around literally with a C-V2X OBU in their vehicle that was SCMS enabled. We got this data and we're like, what the heck? Who's doing that? I don't think any of you have one of those in your car. Probably not. Maybe it was one of you guys. But we're getting that data every day, which is just fascinating. And one of the interesting things about that's when this technology becomes real, where it's like we're just getting anonymized data from cars, and we can dig into it and say, okay, yeah, this guy was going this fast, and he turned on his windshield wipers. I wonder if it was raining that day. And you can go back and look, oh yeah, sure enough, there was a 70% chance of rain that day. Very interesting stuff. So pretty cool to really get into the technology and see how it works. As part of this, Brand Motion has signed on as a partner to provide an HMI interface for these vehicles, which is going to be essentially like a little screen that sits on the dash. So all of the application alerts will appear in a clear screen showing, crash ahead, weather warning, whatever you want to call it, but a very slick interface with the driver, not just a tablet, or something sitting on, a docking station or whatever, built into the vehicle and looking like part of the vehicle. And we're exploring a further partnership here with the freight providers that serve the plant. So very similar to the Ports Authority project, this is how do we get these parts in and out of the plant and help their operation. You heard the lady from Kia talk about understanding where things are and how do we line up our employees and our resources and our operation to match the pieces and parts that are coming in at any given time. Well, part of what we hope to do is have this system enable that, right? So she will always know, well, that truck's 50 minutes away and it's coming on this way. Let's run priority, get it in there quicker, and they can introduce that stuff for the next model line as it comes up across the day, because we're about to start Sorrento's, this hour, and it needs this part. If we can get it there quicker, They can start producing those Sorrentos at a vehicle a minute kind of thing. So that's how we hope to help them just from an efficiency perspective through this technology. Pretty cool stuff. So our path forward, I'll talk about a couple of these, but focusing on our own is something we can't lose sight of as a state. We talk a lot about the safety and mobility benefits of connected vehicle technology. That applies to the state as well. We have pretty big vehicle fleets. We have a lot of folks driving. You know, we could probably calculate the VMT driven of just GDOT employees every day, and it's probably astronomical. We're all across the roadway system any given day. How do we have this technology help our own? That's something we want to explore through our own fleet and our own drivers. Continuing to explore regional partnerships. We like where we're going with ARC and how locals are signing on to this technology and looking to do stuff and embrace the technology and identify use cases and applications. Continuing to look at how technology evolves, where it's shifted now from DSRC to CV2X. We want to be at a position where we can pivot very easily as well. And I think we are in that position through our programmatic approach. Whereas we are retiring DSRC through the final rule through the FCC, we can adjust and pivot. And then as CV2X changes to something else, we want to be in that position to adjust and pivot again. And then open data, getting the information out there. We don't want to hoard all of this information. We want to make it available to industry as a whole for academic use, for OEM use, for local government use, you name it. Again, taking advantage of it and putting it to use. So focusing on our own, this is just a graphic from our ATCMTD application where we are deploying OBUs into all of our Hero unit vehicles. It's 150 vehicles that we're going to be deploying to develop that preemption application across the Metro Atlanta region. The specific use case we are developing is going to be at North Avenue for that turnaround. The reason we identified that specific one is because that's also where Emory Midtown Hospital is. And Metro Atlanta Ambulance Service, who's a partner in this project, serves 100% of emergency drop-offs for that hospital. So we're going to equip their ambulances as well to help them on their drop-off of critical patients. So that's going to be our specific use case we're focusing on. But again, as the application is developed, as the Hero trucks are equipped, we could very easily translate that to any other interchange within their patrolling territory and run very similar use cases as we identify them. So very excited. We are just getting underway. We're expecting the final signatures on this contract any day through both our commissioner and Federal Highway to begin this work and get this going. And then open data access, just highlighting this real quick. Again, making this information available to any that want it. We have developed an open data platform that anybody can subscribe to. Call Alan, he'll get you set up. He'll start pointing that data your way so you can pull it down, explore it, use it, and take advantage of it. How many subscribers do we have now? A dozen, something like that? And these are subscribers like Google and Audi and Volvo. Like, these are pretty big guys that are saying, yeah, we want that information, we want to use it. Google's using it for their map algorithm. What exactly they're doing, I have no idea. But they say it's helpful, so okay, yeah, sounds great. We want to continue that proliferation and attract folks to use this information and do something with it. So I'll leave you with this. The future of V2X is full of challenges. Standards still need to be developed and understood. This is, safety-driven applications. It's got to be done right. The technology piece needs to be understood. Where are we going? What is the predominant technology that's going to be utilized? And what is the path that's going to be walked as an industry that we can all understand and all follow so that we can have certainty to deploy? Because I think that's what we're seeing on the OEM side is folks aren't quite sure what's going on. Why should I put this radio in my car now when I don't know that that's going to be there for the long term? Regulatory certainty is needed so that folks can have confidence to invest. We need fleets to step up, whether they be public or private, so that the technology can begin to work. And we've got to understand this FCC uncertainty, the adequacy of their 30 megahertz proposal that's currently paused, but it is their final rule that we're reducing the safety spectrum to from 75 megahertz to 30 megahertz. What does that mean for potential for interference for unlicensed devices that are sitting directly adjacent to that band that may create packet loss and make some of these applications not viable? And then if it is going to be 30 megahertz, how do we prioritize applications? Do we elevate the safety applications, and then for mobility ones say, okay, well, this just isn't going to operate in that spectrum. It's just got to be a different way to make these things possible because there's just not enough capacity. We've been very involved in those discussions, which has been exciting. We're actually helping out ITS America with some research work specific to those issues. And I mentioned earlier, we participated in interviews with the Government Accountability Office that is examining the rule and order and final rule that the FCC pushed out for this specific issue. So they're listening to us in terms of our perspective and how they could potentially adjust course or refine their approach just from a clarity perspective. So just one last quick note on electric vehicles. When we were all by the pool yesterday, the governor had a press conference, which was pretty interesting. And the state of Georgia has now created what's known as the Electric Mobility and Innovation Alliance. And the purpose for this is to offer policy recommendations intended to further enhance the state's attractiveness to the electric mobility industry and foster innovation related to things like autonomous vehicles, connected vehicles, battery technology, and you can see they're standing up 5 committees ranging from supply chain, infrastructure, workforce, etc. This initiative is going to be housed in Georgia Economic Development, which is kind of interesting. But they got a website, georgia.org/mobility, that was stood up yesterday. So I encourage you guys to take a look. What this means from a GDOT perspective, I have no idea. Are we going to be involved? I hope so. I think it's important that we are, but we don't quite know yet. But obviously, this was a big announcement that he made yesterday. Really, the governor saying, hey, we're going to participate in this electric vehicle thing. I don't know if it's going to be charging stations, policy efforts, legislative efforts, tax credits, who knows. But it's something I think we should all monitor because this is the governor saying, yeah, this stuff's interesting to us and we're going to be a part of it. So with that concludes my presentation. Thank you. Any questions?
Hey, yeah, I had a question regarding specifically like tolling on the hot lanes and express lanes.
Yeah.
Has there been any discussions about integrating that with some of these onboard units? And if so, are those two systems compatible or are there challenges with it?
That's a good question. So the standards organization that oversees electronic tolling and ensures that and certifies that an electronic tolling system is operating within standard is an organization called OmniAir. And they're a private organization that have sort of inserted themselves into that process to say, hey, we'll be the clearinghouse, that if you're going to use this Neology system or this ETC system or whatever it is, we can assure you, toll operator, that it's done in a compliant way. Well, they have also stepped in from a CV perspective, from a roadside unit and an onboard unit perspective to say, we want to be that organization that certifies these devices to say they're being done in compliance with standard, right? They're built a certain way, they communicate in a certain way, all towards the notion of interoperability between devices. So it's the same body is serving both of those roles, which sort of infers that, okay, well, if it's the same people, there's got to be some communication there between tolling and connected vehicle. I can't point to anything specific to say, okay, these guys are doing tolling through a connected vehicle application, but it's certainly possible to do that, right? The one wrinkle in that is you're talking about financial transactions. And toll operators like to treat financial transactions differently. Anybody that's been involved in a CERTA-involved project in laying out the fiber network know the headache that can provide, right? To say, how do I keep CERTA separate than GDOT? How do I keep the money separate from the mobility data, right? We've got to figure that out. That same thing's going to come into play, I think, as you talk about financial transactions being handled through the 5.9 safety spectrum. What different is going to be required? How do you protect it differently? Things like that. But I think it's certainly possible. So good question.
So Andrew, from a local agency standpoint, you probably don't hear it enough, but we really appreciate the partnerships that we get with GDOT. The one probably most impossible task that y'all have achieved in the last decade or so is getting local agencies to actually agree on signal timing, signal operations. I talk with a lot of folks all over different regions, different states, and they all look to Georgia and say, how is it that you guys talk to each other so much and agree to get corridors to time together? What are you doing special? So that, I don't think that that's ever been mentioned in any of these, that y'all are doing a great job with that. The one thing I do see is about 20 years ago, there was a big project that put 2070s out statewide, and 20 years is a long time in technology.
Yeah.
Are there plans by GDOT to move to potentially a new signal spec, ATC, a TS2? Because I think we're starting to bump up against some of the limitations of the TS1 332 spec.
Yeah, yeah. No concrete plans for that specific issue. But as we develop plans or feel like we need to roll something out, that'll certainly be communicated when we get there. But nothing set in stone in that regard. To your first point, I just want to say I really appreciate that. Appreciate that comment. I think a lot of that was necessity. You guys know how the Metro Atlanta region is fragmented from a jurisdiction perspective. If we were going to do anything for managing traffic, it had to be done holistically. And the credit goes to Grant Waldrop, Chester Thomas, no longer with the department, Alan Davis, Kate Sheeran, Victoria Coulter. The folks that have been managing those programs over the years have made it become what it is today. And it's just been that continued push, that continued effort to engage. I shudder to think that if the department said we're going to shut down SIGOPS, what would happen? It's a little like the HERO unit, where HERO doesn't have to be there, but it's expected because of the history that's developed around that piece of the department. The same thing has happened from a SIGOPS perspective, our top SIGOPS perspective, that it's now an expected service. And the great things you guys do as industry to support that. You know, when I tell the story about the 85 bridge collapse, about how we had new timing plans up and running within like an hour, to reroute traffic, folks are like, what? How the heck did you do that? I mean, there was still fire burning from the bridge, and we had new timing plans up and running to redirect people. So, I mean, that's incredible. And those are the stories that people hear, and they're like, wow, how do we do that in, Florida or you name it? So I think it's testament to this entire industry and the strength of our industry in Georgia that has made that possible.
For local municipalities who are interested in the GDOT software on their off-system roads, how do they initiate that request, and what is the timeline or process for doing it?
Call Alan. Or Kate. They'll make it happen. We can address that very quickly. Any others? Oh, we're over time. I'm sorry. Thank you, guys. Really appreciate it. Thank you.
Thank you, Andrew. So this concludes our session. Thank you for your attention.
Thank you very much. I have a couple announcements. So, thank you very much, Andrew and Felipe. It was a great presentation to conclude the session and conference also. So, there are PDH certificates over here. If you have missed from the previous sessions, they are all in the registration desk. So please grab them. And if you have won any items from last night, scholarship auctions or birdhouse, please come pick up. Especially Chris Maddox. I don't know what he won, but Bill gave me a memo that Chris Maddox, please come pick up. All right, for next year, it's never too early to book a room for here at King & Prince for next year. So July 17th and 20th next year. So we'll be here. It's gonna be great. I hope so. And please come back and have fun with us. So with that, I just want to thank everyone who contributed to this event, to make this event a successful one. Bill, all the sponsors, Bill Wilson, the conference chair, Robinson, and Paul, thank you for making this hybrid conference a hit. This was great. All the committee chairs and members and all of the participants, thanks for coming out and having fun with us. So thank you very much, and have a safe trip back home. See you next year. Thank you. Do you have anything to close up? Thank you very much.